Hi, Dominic. Hey, Dominic. How you doing? Oh, Gareth.
Hi,
Oh, here
Dominic's on
you
the
are.
way. There he is.
Sorry. Welcome. Welcome and congratulations for making it so far. So, as you know, you have 6 minutes to pitch. We have a anxious audience here to listen to that pitch. If you're ready, we can go.
I got it. I just want to check one thing before I start. Are you seeing my screen?
No.
Right. Okay. Is that now? Sharing?
Not yet.
No.
We're
This
seeing
is
you.
very peculiar. Okay. And now, I'm sorry. Right.
No worries.
Okay. Here we go.
Now we're sharing.
We're
Brilliant.
good. Okay. Thank you very much. Right. Thanks, everybody. Without any undue delay, I'm going to just press on with this. On the call today, there's me, Dominic Quennell. I'm the CEO and a co-founder. With me, co-presenting is Gareth O'Brien, COO, and another co-founder. And what I want to talk about is a problem that confronts utilities, and that is losses in grids, which amount to, according to the IEA Sustainable Recovery Report, amount to around about a cause of 1 gigaton of CO2 emissions every year. And the IEA estimates that if we could bring losses worldwide towards a level closer to 5%, we could reduce that by about 40% or so by 400 megatons. And among the things that they suggest could be done are replacing transformers, replacing lines and cables as they need to be replaced at the end of their useful life, and finally by optimizing the reactive power profile. Now, those are all things that we can do with our solution, which is the capacitive transfer system. Fundamentally, what it is an innovative AC cable for T&D grids and for on and offshore renewables. It has up to 50% lower losses, conventional cable of the same size. It has a 10% higher power delivery capacity. It has a 20% reduction of overall system reactive power requirements. And mainly, it can, most importantly, can be made on existing cable making equipment. It's a system. There's the cable that we've talked about. We also have joints, which we have had produced and tested by one of Europe's leading Lovink Enertech. And we have a control system, which is really for protecting the cable, but also means that what your substation sees is exactly what it would normally expect to see. Gareth will talk us through the layered version of the cable now.
So the cable on the right, you'll see you've two different colors there, but that's because we've tinned one set of the copper strands to for identification by jointers. It's agnostic as to whether it's copper or aluminium. You can do it with either, and you've got layers of copper separated by layers of dielectric, all existing materials. All the changes we've made are in the core, and everything outside the core of the cable remains as is, the sheet, the screen, etc. Capital advantages in terms of putting the cable in. I won't read all of this because there isn't time, but basically able to go longer distances, able to go underground in situations where you might typically go overhead. It's harder and harder to get way leaves and permissions for overhead. It takes longer, delays projects. Lower power input means you can go with smaller cables. You can reduce the size of step up, step down transformers in some scenarios. And you can either reduce the size of reactive compensators or sometimes do away with them completely. There's no capex typically required in the factory to manufacture the cable. It can be made on existing equipment. Operationally, there are again certain circumstances where you can lower the operating voltage. You might be able to run at the whole line at a lower voltage. Self-compensating mode means you can use it to manage the network. It doesn't have to be having its supplementary capacitance on all the time. That can be controlled. Reactive support's particularly important with non-synchronous sources. Wind farms, solar farms tend not to produce reactive power. In fact, in many circumstances, consume it. supplied at a lower voltage drop means you're pulling less current. Ultimately, mean that's where your losses improvement comes from, and of course the losses with the square of the current. The all of that adds up to a lower carbon footprint.
So basically, we have three technology variants where we can deploy the cable. We've talked about grids. There's another application for the provision of fixed electrical ground power for airports. And finally, we have wireless charging for EVs at a large scale. So we can have one converter, multiple charge pads. And really importantly for grids, this enables a realistic participation in vehicle to grid. We've done a number of case studies with the cable that we've already manufactured, and we have seen the benefits that Gareth's been talking about, and I'd like to come back to these in the Q&A. I just want to talk a little bit about what could be an ideal demo pilot project. I think the first thing would be using a project that you already have planned. Our cable, as it currently stands, is designed for underground and something around about 15 kilometers. As Gareth said, undergrounding is increasingly a requirement. Size, probably 630 millimeters squared, 1250 kc mil. In terms of the cost, the trench is going to be a little bit wider. You're going to end up with two cables in side by side, if you have one alongside a conventional cable. And the actual cable cost is about 15% greater than for a conventional like-for-like cross-sectional area. Of particular interest, I think, to AEP, we've looked at the IRA in more detail than most Europeans have, and we see so many applications of CDS where you could benefit from that. But that's a very quick romp through, and we'd love to take your questions in the time that remains. Thank you. Pitch room's
on mute, yeah.
Pitch room is still on mute. Oh, hi.
Dominic and Gareth, can you hear me?
Yes, we
can.
can.
Now.
Great. Well, thanks so much for your pitch today. Since you alluded to it, Dominic, I think we'll just start with the building off the case study. Can you talk a little bit more about the analysis that you've done, any kind of comparison to conventional technologies?
Yes, I can, but I'm going to let Gareth talk through that because he's the engineer in the room.
I'm the nerd. This is off a model we did, modeled off an actual project in the UK. The intention for the pilot is not to replace an existing cable. It's as Dominic said, to take a project that's already going ahead and add this to it. That way the pilot risk is reduced. We modeled such a project, and as you see there, saw a great reduction in the voltage drop. Ultimately, because the voltage is supported at the far end of the cable, we need to pull less current to deliver the same power. All of the effectiveness of this cable is typically measured in terms of additional power delivered through either the same amount or a smaller amount of copper. And therefore, you could go with a smaller cross-section cable, or you can go with the same cross-sectional cable and push more power through it. It's up to you. The reactive power input to in this particular model, we were looking at a wind farm that was pulling 10 megavar of reactive power to support its load, and that went down to 0. So in that particular circumstance, the self-compensated nature of the export cable was able to replace a reactor.
Great, thanks for that. So a follow-up question, can you talk more about your product roadmap and the timeline and expectations there?
Well, we've been developing the cable over the last 9 years. It's now 4 years since the first commercially built some made in 2 European factories. One was Cobalt in Portugal, the other one was Tratos in Italy. And those cables are all designed for up to 33 kV with a 300 square millimeter cross-sectional area. Going forward, we see that we focus mainly on distribution more than transmission, number one. There is definitely scope to increase the voltage that we're pulling or carrying through the cable at the moment. The testing that we've done so far has been in a single phase mode. We have a test in the ground in the west of England at the moment, which is going to be converted over to running 3-phase in the middle of this year. But right now, what we have in the ground there is a 300 square mil cross-sectional area single phase cable. So we've been solidly testing and have built up an enormous amount of data, which we're very happy to share with you when the right moment comes.
And then can you talk more about the other markets that you touched on, the aviation and the wireless EV charging, kind of the expectations for commercialization there?
I can babble on about a lot of that all day. The airports are a very good target because they have at the 400 hertz is for everything bigger than your average light aircraft. So everything turboprop, everything jet is at 400 hertz, primarily because it makes all your motors smaller. And weight is everything in aircraft, right? But when you're on the ground, typically you'll have seen the third engine, the APU, running on the back of the aircraft. Throughout Europe, from 2025, any contact stand, that's absolutely forbidden. And from 2030, anywhere on the field, no APUs. To date, in a lot of cases where they're not running APUs, they're using diesel gensets to supply the power to the aircraft when it's on the ground. The guys at Heathrow described them as having developed over the years from being airplanes to being flying server farms. So most of what the power that they need at the gate is actually to keep all the computers running. That 400 hertz power is today supplied on a one-to-one basis by equipment that's at the nose of the aircraft, which means baggage handlers can drive into it, it's out in the weather, and it's one-to-one. There's zero diversity, right? And so what we're proposing is a microgrid at 400 hertz, which allows you to centralize all of that equipment, shelter it, service it landside, which means you don't have to accompany people out onto the field. So there's CapEx, there's savings, there's OpEx savings. You're taking the converters down to about a 45% diversity. The wireless EV market is 85 kilohertz. Today, from converter to pad, you're looking at about 7 meters maximum. We've tested at 120 meters with a supplier in Germany, with a developer of pads in Germany. And we've got discussions going with fleet operators such as Royal Mail of 42,000 vehicles, Stellantis, who are a large manufacturer of automobiles worldwide. We see this as being critical because typically, I see we've only 1 minute left. I told you I could go on.
Garrett, can I ask you
Stop. There's a question.
Yeah. Two quick questions. First of all, can you comment on what TRL level you think this technology is at? And secondly, have you considered offshore applications? Can you comment on its suitability?
Yes. So TRL's about 6 to 7. It's been a large amount of focus in the 50 hertz range. The developments on the other two are the 400 hertz and 50 hertz will both be in about 7. The EV one is earlier in development simply because 85 kilohertz itself is early in development. We're in the process of a project in the North Sea to put in a microgrid for offshore platforms. The cable's in the process of being marinized and its joints marinized as part of a net zero technology center project based out of Scotland.
Okay. Thank you very much for your...
Sorry for talking too much and too fast.
No, I think that was just perfect. Thanks so much for your pitch, your questions and answers. We'll get back to you very soon.
Thank you very much. Thanks, everybody.
Thank you. Sorry?
So, Gareth and Dominic, you can just click the button down on your bottom right corner and leave the room. Thank you.
Okay, thank you.
We decided only questions from here. They can ask you to ask the question. Yeah. No, okay. So, but if they tell you what the question is, we can have you ask a question. Okay. Yeah. Hey, Sebastian.
Hello, everyone.
Hi, how you doing? As you
Good,
can
thanks.
see,
How is everyone?
we have a full room here, anxious to hear your pitch. As you know, you have 6 minutes to pitch, and then we have 6 minutes Q&A. If you're ready, up for it, let's go.
All right.
All right, good luck.
Thank you.
Perfect.
All right. So, hello, everyone, and thank you for your time today. My name is Sebastian, and I'm a product manager at GridEdge, which is a data science company that's working to reduce carbon in the built environment. GridEdge was founded to help solve problems related to grid decarbonization from the end user's perspective while bringing benefit to the wider generation and distribution network. Some of the challenges we've seen which have impacted both sides of the meter on the decarbonization journey are network capacity constraints as the heat and transportation technologies are electrified, being able to see and predict individual consumption on a building level and how this aggregates on a larger scale, and maintaining security of supply while minimizing the operational impact for building users. So having seen these challenges, we've identified some opportunities that our technology can help to unlock. These include accessing an estimated 46 gigawatts of positive and 40 gigawatts of negative flexibility. This is only from cooling assets and in the US alone, while the wider flexibility opportunity is much larger worldwide. The other opportunity is to use predictive AI to minimize the impact of normal operations in commercial buildings, which helps to get more customer engagement and to get wider buy-in and wider market access. The third opportunity we've identified is providing capacity management to help delay or prevent substation upgrades, which can result in lower costs from the network perspective and for the customer's perspective. So why would you want to work with GridEdge? We've already tested this concept in a small-scale proof of concept project with a site that has vehicle-to-grid capability, on-site solar generation, and heating and ventilation and air conditioning systems. So throughout the last 2 years, we have tested our functionality and used predictive AI to model the building demand and help control the building and other electrical assets in tandem with this. This means maximizing on-site solar generation while trying to minimize export to the grid and minimizing the demand spikes at times of wider grid demand. So now this project that we've undertaken as a proof of concept has been running almost unaided for the last year, and we're fairly confident in this technology. The next stage we want to do is I've just skipped over a little bit here. This is our case study, which I'd be happy to provide to anyone who requests it, should you get in contact with me after this. So the project we'd like to do is to implement the similar one, but on a much wider scale. So this would be accounting for the impact that it has on the wider system and to provide further benefit to the network operators as well as the customer. What we'd ask for in this project is some guidance on how we can develop our technology in a way that further benefits the network operators such as yourselves. And we'd expect this to take place over about 14 weeks with a total project cost, including hardware and labor, of 121,754. Keep in mind, this is a rough estimate, but this is based off the numbers we've worked on so far. The output of this project would be to have a site fully deployed and fully functional, and to have the functionality fully tested and to see the benefits of grid and building operation in tandem, working together, to help kind of iron out any of the pain points that arise, with the hope of scaling further afterwards. We have a list of the risks here, which is largely accounted for by our previous experience and for our previous customers. But the reason we're coming to the free Electrons program is to be able to access the scalability that network operators can provide, and to hopefully get both of our technologies and knowledge working together to help decarbonize the grid into the future. So thank you so much for listening to this pitch, and I'm happy to answer any questions anyone has at this point.
Hi there, thank you very much for the presentation. This is Saoirse from the ESB. So just to start off, you mentioned the case study there and how it benefits the grid, but I suppose what's the benefit to the customer or the building owner?
So the benefit to the customer and the building owner would be reduced electrical costs. In this case, you'll see the yellow bars are electric vehicle, in this case, vehicle to grid, so the ability to charge and discharge. The neon line here is a grid price signal, although this can be changed for either a grid carbon signal or for using, for example, open automated demand response to respond to a wider signal from the network operators themselves. So we believe that there's a net benefit that can be shared either between the distribution operators or the suppliers and the customer.
Okay, and maybe can you discuss maybe cost versus savings? So how does the cost model work? Is this a base price or can you guarantee a minimum savings to the customer?
From the operational perspective, we have a wide range of savings we can show to the customer. It really varies building by building and depending on which assets are in place. But we'd say on average about 15% for a building that has electric vehicles, heating and ventilation, and on-site solar generation, or even heat pumps, for example.
Okay, and how would you deal with the challenge, I suppose, of low quality of data, or what BMS systems do you integrate with? Are there certain ones that you need to integrate with, or a certain level of data collection that you need for this to be beneficial?
Definitely data quality is a big requirement. We have been able to go in the past and install a light BMS of sorts, and also using some IoT sensors to kind of supplement the existing data sets. We can also go in and install submetering, which helps to increase the quality of the electricity consumption data, which helps with predictive modeling.
Okay, and then we've seen a lot of systems like this in the past. If you could sum up kind of what's your secret sauce or what helps you differentiate from your competitors?
Yeah, there's quite a lot of companies. We've seen ourselves in doing this in the past. So I think the major thing that would distinguish ourselves from this is the prediction element. We haven't seen much of that in terms of predicting the impact of turning down a heating and ventilation asset, for example, on the user internal comfort levels. So we're able to show that over these next period of time, if you were to make a change on your heating and ventilation loads, it would have minimal to no impact on the internal user comfort. And this we found helps build a lot of confidence in our technology, which we haven't really seen elsewhere in similar offerings.
Thank you.
Johnson from AEP here. I'm curious about your customer acquisition strategy and how you see that playing out. It sounds like you've got a few customers online so far, but how do you see that scaling in the future?
We've been trying to move to sales through a partners model. So we have done a lot of direct sales in the past, although we found that for better scalability, selling through partners is definitely the way to go.
And just one more, of the flexibility you've been able to create, you have your costs on top of that. I'm curious what the range of cost per kW looks like to get this flexibility.
So this grid price signal here varies on a half-hourly basis. So this is actually the UK day-ahead pricing, which we've been able to optimize against. The average cost was at this time was about, based on a couple of years ago, so this was 15 pence per kilowatt hour. But the varied price signal went from 0.04 up to, I think it was 35 pence per kilowatt hour. So there's quite a large range in terms of the pricing from the grid signal.
I suppose from the utilities here, have you a target utility you'd like to work with or a geography you're aiming to expand into?
We've worked with UK networks, but we have looked into potentially working in towards the US market, especially as there's been a lot of development in that region, well, from all sides, it seems. We're also looking into more Eastern markets, as we have some experience in some of the more beneficial components of the technology, such as capacity management, which seems to be much more prevalent in those areas.
Hi, John here from ESB. In terms of the low-hanging fruit, what type of customer are you targeting initially to get the best bang for your buck?
Typically customers that already have building management systems and heating, ventilation, and air conditioning, and are looking to implement electric vehicle charge points of their own. Also sites with, oh, sorry.
Yeah, is it like a Tesco's or is it a commercial office building or what kind of?
So most of the ones we've worked with so far are commercial office buildings, although a Tesco would be quite beneficial as the site's a lot larger, which means a larger benefit for both the customers and for us and the network operators.
Right, thanks very much. Any more questions, anybody? Yeah, we have one from China.
Ivan from CLP. I want to ask whether you have any pilot projects before with any building management system OEM, like Johnson Control, Siemens, etc. Have you done any pilot projects before with them?
Not directly. We've worked with their BMSs and we've been able to integrate with most of them, but we haven't directly worked with them in partnership.
If you haven't come across, how do you know? You have confidence, right?
Sorry, say again.
Or any special BMS company that you have already pilot with? Can you tell me?
So the ones we've integrated with in the past have been Trends, Dema Controls, I think Mitsubishi. I know we've interfaced with their heating and ventilation systems, not necessarily their BMSs. That's all I can think of right off the top of my head.
Okay, Sebastian, thank you very much.
Thank you, everyone. I appreciate your time.
We'll get back to you in the coming weeks. Thanks.
Thank you very much.
Okay, Sebastian, you can click on the bottom right button of your screen. It says leave room. And thank you so much.
Yes. Hi, Michael.
Hello there.
How you doing? Welcome. So we have here 7 utilities really anxious to listen to your pitch. As you know, you have 6 minutes, and then we have 6 more minutes for some Q&A. So if you're ready and up for it, let's go.
Excellent. I'll just share my screen.
Yep. Popping up. Here it is.
Excellent. Well, hello, everybody. My name is Michael Jari. I'm the Managing Director for Sense in EMEA and APAC. I'm formerly Head of Retail Strategy at British Gas and SSE and Director of Connected Home at SAC and MD at Verve. So clearly, one of the most vital challenges of our times is the energy transition. Delivering it will be expensive and complex, but we cannot clearly afford to fail. Consumer bills are rocketing, putting public support at risk. Renewables, distributed generation, and the electrification of heat and transport is putting incredible pressure on the low voltage grid. However, Sense has developed a solution founded on AI that tackles these problems and cost effectively accelerates the energy transition. By analysing energy signals at very high resolution, Sense is able to identify in real time what home appliances are in use and how much energy they are consuming, and spot malfunctions too. Similarly, on the grid, Sense can identify and locate faults such as vegetation brush and corroding transformers, and provide other grid edge insight such as power quality. And these capabilities in turn help to engage consumers and reduce their energy bills, deliver domestic demand side response at scale, and improve short and long-term load forecasting, provide grid edge insight and fault detection for networks. Our software runs on standalone monitors such as this, or third-party smart meters such as this Lamson Gear smart meter just here. There's no other hardware in the home required. This means it can be rolled out at scale across entire smart meter rollouts at the low marginal cost of software. Now, on the left of your screen just there, you can see the consumer app, hopefully, I'm holding it right now. Now, this is running in my home right now. You can see the bubbles indicating that the electric vehicle is charging, that the TV is on. The bigger the bubble, the more power it's using. You can see early in the day what's happened so far: freezer cycling on and off, washing machine was on earlier. You can drill into specific devices such as let's see now, my coffee machine. This uses, an awful lot of power for a coffee machine, 6.8%, because I leave it on standby for too long. You can see the various devices that are detected in real time by this application in my home. Everything from carpet cleaners, coffee machines, dishwashers, freezers, ovens, vacuum cleaners, washing machines, and so forth. And you can also have a historical view, helping me to zero in on those appliances that are using the most power in my home. So far this year, you can see my electric vehicles use most of my power, 26%, but that cooker boiling tap at 9%, coffee machine at 7.6%, that's really helping me identify where I can make the most savings. My underfloor heating used to be 15% before I realized just quite how expensive that was, such a large proportion of my total bill. Now, of course, in a demand side response event, I would most likely be sent a notification asking me to turn off my electric vehicle. My neighbour may be asked to turn off their hot water tank. Every home is different, and that's the power of Sense, that we can ensure high participation and a lot of load and flexibility events, because we make it very, very simple for consumers to respond. Now, the average Sense consumer saves about 9% on their energy bill, and up to 25% for more engaged users. Our domestic demand side response has been shown to shift 18% from peak load. That's 3 times higher than best in class. And our grid and power insights can save hundreds of millions in costs for both networks and retailers. Now, many startups have attempted to do disaggregation before, but Sense's technology is genuinely a class apart. It is alone in being able to reliably identify small and large appliances in real time with 95% accuracy. It's alone in being able to find and locate faults on the grid. And directly because Sense detects at an appliance level in real time, powerful new propositions are unlocked. It creates value in the home and on the grid for consumers, retailers, and network operators. In recognition of this, Sense recently raised the largest ever round in the NILM sector. We raised $127 million in our Series C. We're partnered with the 2 largest meter manufacturers in the world, Itron and Lamson Gear. And so far, over 3.5 million Sense-ready utility meters have been purchased by utilities. And we're pleased to be recognised with a number of awards over the years. What we're proposing is pilots with retailers, network operators, and integrated utilities using either our standalone monitor, this little red box just here, or preferably in conjunction with your preferred smart meter provider as well. As part of the exercise, we will localize our machine learning applications for your market, deploy to a minimum of 100 consumer homes, we can do more, and jointly prove out a compelling business and consumer use case over a 6 to 12 month period. Thank you, and I would love to hear your questions.
Thank you. Yep, let's have some Q&A now.
Thank you for the presentation. My name is Ivan from CLP. So my first question is, what is the minimum data, smart meter data resolution for effective load disaggregation? Just like what you described,
Yeah, so very good question. So Sense only operates on next generation smart meters and at a minimum about 15,000 samples a second. And I know that is high, but the crucial thing to keep in mind is that that resolution of data only stays on the smart meter. It's a grid edge technology supported by cloud operation. So whilst we sample at 15,000 samples a second in the smart meter, we actually only communicate with the cloud far less frequently. And as I say, this kind of resolution is now increasingly common among next-gen meters. It's now specified by ESMIG, industry body in Europe for smart meter manufacturers for next-gen meters, and it's also part of the Landis and the Archon meter as well.
What is the accuracy that you think you can achieve based on this data resolution?
Yeah. So when we identify an appliance, we only surface it in the app if we are 95% confident that we will accurately, that we'll find it 95% of the time. So 95% accurate in terms of ons and 95% accurate in terms of off. So 1 in 20 times is the maximum error we'll allow when it comes to detecting devices.
Understood. What is your recommendation if a utility already using Landis and Gyr smart meters, but they collect the data at a much lower data resolution because data transfer, everything is cost?
Yeah. So unfortunately, low resolution data can't do real-time device detection. It does need to be tens of thousands of samples a second. When you drop below kind of a second level, that's when you can't do real-time. That's when it has to be historic, backwards looking. Because if it's backwards looking, it's just not as valuable. It's no value to a demand-side response event. Consumers aren't as engaged with it. So unfortunately, if it's low resolution data, the use cases that are available are just materially diminished. They're not as, can't do real time, can't do appliance level. I've been through this process when I was at SSE, actually being a buyer for this kind of technology, and I've had my fingers burnt, and I've realised that high resolution is kind of the only way ahead.
Hi, it's also Brendan from CLP. Hear you on the sample rate. What about the communications rate? I think we communicate, Ivan, I think about 1 in every 15 minutes, right? Is that adequate for you as well?
So,
or 30, even 30 minutes, was that adequate?
We use 2 comms approaches. So we use, for the real-time experience, as in what you're seeing on the app right now, we ask the consumer to connect their Wi-Fi to the smart meter. And that means it's obviously instant for the consumer, it's instant for the grid as well, all those kind of use cases which require an immediate reaction. That said, we can also operate via the backhaul, but what we do is we squash up the insight, we batch it up, and we deliver it on a less frequent basis. You know, one of our clients, we provide it the next day. They still get to see the total device breakdown, but it's just not real time. That data sample is very low. It's once a day. It's de minimis. But even the Wi-Fi data flow is just 1 data point per second, as in what devices are on, what devices are off, and that goes into the Sense cloud. It's not a burden that the network has to manage.
Hi, this is Tomasz Murin from EDP. Thanks for your presentation. A couple quick questions that you touched upon in your presentation, but so one is, do you need an electrician to come and install this, or is it plug and play by the client?
So when it's software on the smart meter, it as the meter gets installed, then all of the processing power is ensconced within the smart meter, so it's just part of the smart meter installation process. And this is, by the way, how we are scaling at the greatest volume worldwide. It's 3.5 million of these we've got so far, and the reason we've got 3.5 million is because it's just software on the smart meter and they're being deployed anyway. Now, if you deploy these, And these are deployed. They're useful for piloting when the smart meter isn't ready for that particular market. We do sell them directly to consumers in the US, sold about 150,000 of these things to consumers in the US. This we do recommend an electrician installs. But I think in terms of what we're talking about piloting here, certainly happy to discuss, opportunities using the orange box. But we're most interested in deploying software as smart meters.
Thank you. And can you tell us about your cost, your revenue model? So is it a fixed cost plus an ongoing subscription, or how do you work?
So we generate our revenues predominantly through performance-based data service propositions. It's our strategy to give this consumer application to end consumers at no charge, because we want to maximize penetration across the smart meter rollout. And there's no history of consumers paying for energy insight; they just don't do it. So it's about giving consumers, a really compelling proposition at no charge. But then once you are in the consumer's home, then you've got the capacity for authorized market participants only to generate some real value in terms of demand side flexibility, substantial pots of funding available for flexibility, and increasingly so in the future. There's material revenue opportunities through I also want to pay for performance basis, identifying faults on the grid and helping the grid operator save money because they're not sending trucks around looking for faults on the grid. We tell them where the fault is and what the fault is. And also we can help deliver mandated energy efficiency consumption programs, which come with a...
One last quick question.
Just one last. Chris Johnson from AEP. The meter, does it have to be configured at the meter shop, or can it be updated over the air?
So if it's a next generation meter set and it has the appropriate hardware, then it's over the air deployment, upgrade and so on. There is a minimum threshold for the capability of the meter. So it very typically is next generation meter rollout. So we're not looking to roll out onto legacy old meters. Unfortunately, they just don't have the metrology there. But 50% of all US meters rolling out today have sufficient capability to run sense, and progressively so across the rest of the world, Asia Pacific, Europe.
Can we just ask you the $100 million question? What are you doing with the $100 million?
We are great question. Part of it, unfortunately, I can't share with you, but a material portion of it is going to funding international expansion, we have our core in the US, but then expanding out, as I said, into APAC and EMEA, as well as continuing product development and integrating onto more and more meter set partners, such that again. Hopefully we're going to make some more announcements in the near future, but progressively working with more and more of the meter players worldwide.
Thank you so much, Michael. We'll get back to you in a few weeks, in a couple of weeks. Thanks. Now you can click, I think, to leave the room, and see you soon.
Okay, thank you. Bye-bye, everybody.
Bye.
Bye, Michael.
Hi, Victor.
Hi there.
How you
Hello,
doing?
everyone. Everything
Hi,
fine.
welcome.
Thank you.
So you have here a room full of utilities wanting to listen to your pitch. As you
Great.
know, you have 6 minutes to pitch and then 6 more minutes for Q&A.
Perfect.
We have your presentation on, so you're ready. Yeah, let's go.
Yeah, thank you very much, everyone. My name is Victor Gaspar. I work at Multiverse Computing. I'm head of advanced computing at Multiverse. Let me change this. Okay, Multiverse is a startup company that was founded in 2019. We're a spin-off of an international physics center. We are currently 84 people. We received some investment several years ago that allow our company to grow to the team that we are right now. As a company, a spin-off from research center, we publish a lot. We have more than 9,000 citations, but as a company, we also protect our knowledge, filing patents. So we have more than 50 patents filed. The total contract value for 2022 was 10 million euros. And we are working with more than 50 blue chip customers. Okay, we have offices in Spain, but also what is our headquarters are based in Spain, but we have branches in Canada, France, and Germany. There are some. Our goal is to develop software, quantum software, for customers to bring value today with using quantum computers, quantum inspired and pure quantum computers. Okay. Basically, the customers challenge us with a difficult, complex computing problem, and we try to solve those problems using the technology available today, some quantum computers available today. Okay, those are some customers that we have right now. We have solved some problems for them, some complex problems for them. Basically, what we do is that we have developed this Singularity platform. This Singularity platform is a computing platform that allows us to do optimization problems, machine learning problems, and stuff like that. We are agnostic to the hardware, so we work with the major quantum computer architectures that are available right now. We develop an API, an easy-to-use API to solve for our customers to access the solutions that we develop for them. So we abstract the complexity of accessing those quantum computers. We abstract the complexity of using quantum algorithms, and we provide an API access to our customer that is easy to use. Okay. We also run on classical computers for our quantum-inspired algorithms. Okay. So one of the problems that I wanted to present today that we solved recently for a customer of ours is this Forex trading problem. Okay, optimizing Forex transactions. As you know, as any company that invests, it's a large company that invests in foreign markets, they need to work with different currencies, for example, dollars and euros, to protect from the fluctuations that the market, the monetary market, the Forex market has, to protect those fluctuations. What the companies do is they implement some hedging strategies. On those hedging strategies, basically the idea is to average these fluctuations that you have on the Forex market. Okay, depending on how you implement those optimization problems, those optimization approaches, you can have more or less profits on your exchange rates. Okay, so what we did for one customer of ours, for BASF, was to implement a machine learning algorithm to beat their current approach. So basically, what we have here is a benchmark that we perform with this customer. On those lines that you can see here represent the classical approach. This is 5 years back testing. So we use data they have for the last 5 years. And we compare in a benchmark their approach with our approach. As you can see, for a traded volume of 5 million euros, we got 1 million euro for those 5 years. We got 1 million euro of profit compared against their standard solutions. Okay, so basically we beat their solution, their current solution, using a hybrid approach, quantum plus classical and artificial intelligence. Okay, so yeah, that's everything I wanted to tell you today. I think I still have some time there.
Yeah, great. We have some questions for you. So
yeah, thanks.
Thanks, Victor. This is Tony from AEP. So I guess the first question I have is, what use cases have you validated in the energy space thus far?
Okay. There are several use cases that we have already validated. For example, one of them is to predict power production in renewable energies. We have a customer, it's a Spanish customer, and it's in Acciona. They have windmills, and we have an algorithm with them. We have developed an algorithm with them to predict 4 times a day the production of energy. This is one use case that we have developed in the energy market. We have beat it by a slow margin, the classical solution, But since this algorithm is run 4 times a day, 365 days per year, the margins are pretty high. So the profit that we can get is pretty high. We have also some projects right now running for chemical simulations of materials for CO2 capture. So this is more research-based, but this is also an interesting use case in energy. This is the one for a petrochemical company. We have several use cases in the energy, and I think that there are pretty challenging computing problems in the energy industry. And what we will try is to bring value now to the customers using what the technology is available right now.
Thanks. A follow-up. So the use case you just talked about, the prediction of production of energy, do you have any kind of analysis on like the cost benefit that that particular project realized?
Yeah. In a 1 month run, so basically the project cost around 150,000 euros. And in one run, in 1 month, the profit that they make in this 0.4 difference against the classical contract part, they were making around 300K per month in profit. So basically the return of investment was in 1 month, 2 months, we got the return of investment for this specific use case. Yeah.
Got it. Thanks. Can you talk more about the customer requirements as far as hardware, software, etc.?
Yeah, this is an interesting question. So in terms of hardware requirements and software requirements, what we provide is a platform that is Dockerized, that you can run on premise or basically on Amazon Web Services or Microsoft Azure. This is the classical part that is running, and then we need access to, depending on the problem, to some quantum computers. But the access to those quantum computers is provided through us. Basically, we do the deployment of the platform in this classical infrastructure, and we access quantum computers that we provide access to through our platform. The deployment is around 2-3 days to deploy this platform, and then the time we take to develop a solution to the problem we are developing, to the problem that we are tackling.
Thanks. Can you talk more about your pricing model?
Yeah. Basically, we have a proof of concept phase. If the project is not, so if the solution that we are providing is not already on the platform. Okay, let's suppose that we are tackling a new use case, something that we don't have already on the platform developed. Basically, what we do is a proof of concept, 4 to 6 months project. In this project, what we do is to develop the algorithms needed to solve that problem. We develop that into the platform. Okay, and then this is something that we charge at some development services for this short project. And then we provide access to the solution developed through an API. This API has a cost of around, for one problem, it has a monthly subscription. What we provide is a monthly subscription to this Singularity platform. Okay, and this is paid year per year.
Got it. Thanks. Any other question? Yeah.
I don't know if you mentioned Repsol and green hydrogen. That seems to be a strange one, considered what you've told us already. Could you explain the reference?
Yeah, this is a research project financed through a research grant here in Spain. Repsol, it's a petrochemical company. What they want is to develop some catalyzers to capture CO2. Okay, so this is a research project financed by the Spanish ministry. This is a 3-year project. Basically, we are collaborating with them and their quantum team to develop these catalyzers, or a solution to simulate how those catalyzers might work in the real life. That's it.
Yeah. Victor, muchas gracias. Thank you very much.
Thanks to you.
And
have a nice day.
Talk soon. Yeah, we'll get back to you in the next couple of weeks. Thank you.
Okay. Bye.